This is part 3 of the Test 6 video review for Math 310. Problem number 11 says find the intersection or union. In A, we have an upside down U, that means intersection, and an intersection is everything that is in all of the sets, but it has to be identical. So in this case, we have nothing that is in all of the sets. We only have things that are in each of the sets. So our solution is that there is no solution, and we write it like that. In B, we have a union represented by a U in the middle, right there. And we have 2, 4, 6, 8 again, union with 1, 3, 5. And union means they are united, that everything in the first set plus everything in the second set is in our solution. And so we write 2, 4, 6, 8, 1, 3, 5. C says we have the set 2, 4, 6, 8 intersecting with 1, 4, 8. Are there any numbers that are in both sets? And the answer is yes. 4 and 8 is in both sets, and that is our solution, 4 and 8. And something funky happened to my bracket, so I'll redraw that. Okay. Number 12 is to solve the absolute value of 9x plus 4 is equal to the absolute value of x minus 11. And when we have two absolute values, we're talking about distances that we want to be equal. So 9x plus 4 can either go in the positive direction and equal x minus 11, or it can go in the negative direction and equal the opposite of x minus 11. So let's write that out. In the positive direction, we have 9x plus 4 equals x minus 11, and in the negative direction, 9x plus 4 equals negative parentheses x minus 11. So let's solve on the right. We're going to subtract 4 from both sides, and then we're going right there, and then we're going to subtract x from both sides. 8x equals negative 15, and all we have left to do is to divide both sides by 8, and then we have that x equals negative 15 eighths. So that's what x equals in one direction. And in the other direction, look at 9x plus 4 equals negative x minus 11. Remember that negative x minus 11 is the same thing as negative 1 times x minus 11. So when we distribute that 1, we get that 9x plus 4 equals negative x plus 11. Now we are going to subtract 4 from both sides and then add x to both sides. And lastly, we're going to divide by 10. So our other solution is 7/10. So we could say 7/10 is the distance in the positive direction, and negative 15/8 goes in the negative direction. Let's check our work. Oops. First, we'll plug negative 15/8 in for x and see if 9x plus 4 equals 11 or equals x minus 11. And then we will do the same for 7/10. Remember to change your 4 into a fraction and then multiply it by 8 over 8 so you get a common denominator. Same with the 11. And I forgot my times 9 here. And so we see at the top of the screen that negative 103 over 8, the absolute value of that, does equal the absolute value of negative 103 over 8, and so our problem checks out. Oh, let me use this pen. Check. We can do the same thing for 7/10, and we will also come out with a correct solution. So the solution is that x can either equal -15/8 or 7/10 to make this absolute value equality true. Let's write this at x such that x is greater than -1 in interval notation. And remember, I always like us to draw our graph first. So here's -1, here's -infinity, and here's infinity. And x is greater than -1, so we're going to draw parentheses for greater than, and then have the line going over to the right. Now we can look at our graph and write what we see. We see that there is a parentheses, and then a -1, and then a comma, and then an infinity, and parentheses always goes with infinity. And that is the answer. In this problem, Peter is paid salary plus commission. He can choose between two plans. Plan A pays $340 per month no matter what he sells, plus 9% of his sales commissions. Plan B pays $627 per month plus 5% of his sales commissions. So when is Plan A better than Plan B? Plan A is $340 of salary plus 9%, or in decimal form 0.09 times your sales commissions, which is S. Plan B is 627 plus 0.05 S. So what we want to know is, when is Plan A greater than Plan B? We set up our inequality to show Plan A being greater than Plan B by substituting the formulas we came up with. So now we can treat this as we normally treat a linear inequality. We can put our numbers on the right and our letters on the left. So we'll subtract 340 from both sides, and we'll add 0.05s to both sides. So if we do that, and I did two steps at once, we will get 0.04s is greater than 287. By the way, I think I said we add 0.05s to both sides, but I meant we subtract it. So now we have 0.04s, and we want s by itself, so we need to divide out that 0.04 on both sides. And what we find is that when our sales commissions are greater than $7,175, then Plan A is better than Plan B. We can check it by plugging 7,175 back into Plan A and Plan B. If S is equal to 7,175, Plan A should equal Plan B. So let's see if that works out. So we're asking, does 340 plus 0.09 times 7,175 equal 627 plus 0.05 times 7,175? We can solve this just by multiplying the 0.09 times the 7,175 and then adding 340 and doing the same procedures on the right. And what we find is that on the left we get 985.75, and on the right we get 985.75. So that checks, and that means that our answer, S is greater than 7,175, is true. Jessi has taken 3 tests in her class so far and earned 82%, 98%, and 69%. Her goal is to earn a B in the class, and she has one more test. So what must she earn on that test to pass with a B? To get a B, she needs 320 or more points. So that means we need to find the test score that will give her either 320 points or greater than 320 points. So let's let the letter T represent the test value that we don't know, and then we are going to add the 4 tests together. Those tests must add up to either 320 or more than 320. So they have to be greater than or equal to 320. Now all we have to do is add the first 3 tests together and then manipulate this inequality so that we know what T has to equal for Jessi to get a B. So when we do that, we learn that T has to be greater than or equal to 71%. Let's check our work by substituting 71 in for T. If 82 plus 98 plus 69 plus T equals 320, then we know that when T is greater than 71, it will be greater than 320. And so we find that 320 equals 320, and it checks. So our solution is that T has to be greater than or equal to 71. So Jessi has to earn that score or better on her last test in order to earn a B. Solve the inequality 42 minus parentheses 2x plus 7 in parentheses is less than or equal to 5 times parentheses x plus 3 in parentheses plus x. This is basically an order of operations problem. So from left to right, we are going to first clear up that negative that is in front of the parentheses by writing a 1 in front of it so that we can treat it like -1. And we're going to distribute it to the 2x and the 7. And on the right, we are going to distribute the 5. Now all we have to do is simplify the left side and the right side. And we're going to do 2 steps at once. We will get the x's on the left by subtracting 6x from both sides, and we will get the numbers on the right by subtracting 35 from both sides. And we get that a negative 8x is less than or equal to 20, or negative 20. We divide both sides by negative 8, and we get that x is less than or equal to negative 20 over negative 8 is a positive, and 20 over 8 reduces, so 4 goes into 8 2 times, and 4 goes into 25 halves. The negatives cancel, so we are left with x is less than or equal to 5 halves. And that is the end of the review for test 6.